I will pair up oxidation and reduction reactions in this video since they are essentially opposites of each other. In these reactions, we often don't identify the oxidizing agent, but it could be something like permanganate ion or some other compound. So we'll often just write an O in square brackets to indicate that we've added some sort of oxidizing agent. So alcohols, when they're oxidized, will become either an aldehyde or a ketone. And that's where the difference between a primary and secondary alcohol will come in. So a primary alcohol will become an aldehyde and a secondary alcohol will become a ketone. You actually cannot oxidize a tertiary alcohol. So let's go over what that means. So a primary alcohol might be something like pentanol, 1, 2, 3, 4, 5, pentanol with an OH. If we oxidize it, the OH becomes a carbonyl group instead, 1, 2, 3, 4, 5, and then a carbonyl group. So it became an aldehyde. So 1 pentanol becomes pentanal. Whereas if we had 2 pentanol, once we add the oxidizing agent, again, the organic product, the OH group becomes a carbonyl or carbonyl group, and now this would be pent-2-one. And we do have to specify here because pent-3-one would have been a different compound, whereas in the previous case it became an aldehyde, pentanal. The reason a tertiary alcohol cannot undergo oxidation, a tertiary alcohol might be something like tert-butyl alcohol or methyl propan-2-ol. I cannot replace this OH with a double bond O because that would be 1, 2, 3, 4, 5 bonds on a carbon. So only primary and secondary alcohols can undergo oxidation. An aldehyde could be further oxidized to become a carboxylic acid. So for example, if I take my pentanal from the previous example, I can take an aldehyde, and if I react it with an oxidizing agent, it will become a carboxylic acid. So we'll stick an OH on the same carbon that had the double bond O. Now keep in mind, we've also taken a hydrogen off here. We're not showing the mechanism, we're just looking at what the organic reactant and products are. You can't do this reaction with ketones because ketones, there's not room to add another branch to the carbon that has the double bond O. And that's part of why aldehydes and ketones are in different families. They react differently, as in this case. So reduction reactions are basically the opposite of oxidation reactions. And here we add a reducing agent, which we actually identify as an H in brackets as a form of indicating reducing agent in organic reaction. So an aldehyde or ketone, if reduced, will become an alcohol. So for example, if you start with an aldehyde like propanal, it could become, sorry, I forgot the reducing agent. So if it will become 1 propanol, okay, whereas if you start with acetone or propanone and you add a reducing agent, you'll get 2 propanol or isopropyl alcohol, which is rubbing alcohol. Okay. If you reduce a carboxylic acid, like vinegar, you may have had a recipe which says to reduce the vinegar and you never really thought about what that meant. If you reduce a carboxylic acid, then it becomes an aldehyde. And likely in a recipe, you're actually further reducing the aldehyde to become an alcohol. Okay, good luck with your practice.